Welcome to my channel. During the summer, the local Dollarama stocked a lot of solar-powered sensors. Since they were so cheap, I didn't feel bad about buying them just to take apart. At the time, I was very curious about solar panels and detectors. However, it wasn't until autumn that I actually started working on electronic circuit projects. I found a very similar product online. The one I have on hand is already disassembled, so I ended up with a PIR, passive infrared, sensor component. Previously, I wanted to use the sensor to solve the problem of automatically turning off the lights in the office, but that's no longer necessary. Now, I'm looking for a fun project to work on, and I thought of a burglar alarm project. The pinout of the PIR component was surprisingly hard to find. Luckily, I found it earlier. When I was about to draw the circuit diagram, I realized that Falstad didn't have the component, so I had to draw it myself too. So before drawing the alarm circuit, I started with the PIR. It took some time to find a suitable PIR circuit. However, the photosensitive material is another thing that can't really be simulated. Just a heads up, my background is in software engineering, not electrical engineering. Some circuit designs may be obvious to someone with an EE background, but I definitely lack that level of knowledge. My video examples aren't meant for formal instruction, they're just the thoughts and experiences of a hobbyist. Based on the PIR's schematic, I tried to replace the photosensor with a switch, and the circuit ended up looking like this. It took me a while to figure out why there was no GND in my circuit. I guess the photosensor was acting as the power source. From the schematic, it does look like a mirrored power source. The schematic had a separate GND line designed for it. But since I was replacing the photosensor with a switch connected to the same battery, connecting it to ground just caused the power to drain directly. After packaging and testing it, it seems to work fine. Now I can move on to drawing the motion sensor alarm. This web page has a few examples. According to the PIR specs on the page, the acceptable voltage range is 2 to 15 volt. While window shopping, I found this small speaker with specs, 20 mm, 1 watt, 8 ohms. Converted back, it can be activated with just 2 to 3 volt. In other words, here you could use an LED in place of the speaker. While drawing the circuit, I first got the PIR power connection working. It looks mostly the same as before the PIR was modularized, with a switch replacing the photosensor. Next, I connected the speaker. Whether the speaker is activated depends on the photosensor. So I used an NPN transistor for current control. It seems that the direction of the NPN doesn't reverse the current flow, but the current enters faster from the collector, C, than from the emit, E. Aside from the photosensor, human ears also need a break. So I added a switch in front of the speaker as well. When I want it to shut up, I can cut its power. After completing the circuit, I noticed that the alarm would stop immediately after motion ended, which made it feel kind of useless. Usually, a moving object just flashes by. With a loudspeaker, it might get cut off before it even starts making sound. So I added a capacitor to the circuit. I tested how long the alarm could keep sounding after power was cut. The charge in unit P and N was too low, so I finally settled on using a 1 μF capacitor. Looks like the alarm circuit is complete. I'll save the file so I can reuse it later. Don't forget the pinout of this PIR module isn't correct. It's time to draw the correct PIR component. The MOSFET inside the PIR requires at least 1.5 V to activate. The photosensor uses an independent power source. After converting it into a sub-circuit, I saved it. Finally, I have a correct PIR circuit. Next, I need to update the alarm circuit using the sub-circuit with the correct pinout. Surprisingly, the correct PIR module kept showing errors. In the end, I decided to draw both circuit diagrams on the same canvas. The open file function doesn't allow keeping the existing circuit, so I tried copying the text files of both circuits into one, but that just made the two diagrams overlap. Eventually, I realized a much simpler method: open the two circuits in separate windows, then use copy/paste to bring them together. Sure enough, the new PIR module worked correctly. I updated the alarm circuit according to the correct pinout. That's the end of the simulation example. See you in the next video.